Thank you. So, welcome to the great adventure. In fact, every time I sign a book, I say, welcome to the adventure, because that's it. This is the greatest adventure you can have, to discover our real place in the universe. For me, for a general audience, it's difficult for me to talk about, actually, because I never quite know how to get the message across, because a lot of what I say is so unfamiliar if you watch standard television science programs. And I say some outrageous things which give cognitive dyspepsia, as I call it, to those who are experts. But the good thing is that more and more experts in various subjects are turning to us, because what we are presenting is a coherent story of the universe, which not only talks about the physics, but it has a huge cultural significance as well. Because Vellikovsky, who's perhaps the chief inspiration for my life's work, pointed out towards the end of his life that it's the cultural story which is most important for humanity's survival. Even the great Dr. Carl Jung recognised that humanity is his or hers worst enemy. And the reason is that we have forgotten our past. We suppress memories that arise because it seems that there is such a thing as a racial memory. And in doing so, we keep repeating the same mistakes over and over again and pushing down our real understanding of the universe. So I'll try and whip through this, because I covered some of the aspects, of course, in that unscheduled earlier talk. Sabine Hossenfelder is a theoretical physicist in quantum gravity, and she writes a blog, Back Reaction it's called, and because she's so well qualified, she has a lot of people who are similarly well qualified who get into the discussion with her. She recognises that things are in desperate trouble in science. And she said, I don't think crisis describes the current situation well, because crisis is optimistic. It means we'll find out a simple answer, a simple fix. It's not that simple. She said, we already know that the theorists' guesses did not work out. And she says, not a single one. And she goes on to say, the self-reflection in the community is zero, zilch, nada, nicht, null. They just keep doing what they've been doing for 40 years. And this is a problem in that science is taught with no reference to understanding how the human brain works and how we are somewhat crippled in doing science by not understanding ourselves. As I said earlier, we have a monologue instead of a dialogue. And to advance, you must have a dialogue. You've got to have somebody asking awkward questions which make you think. Think about whether the things you're saying make sense or whether they fit with the broader picture, because cosmology, a real cosmology, should be able to offer some sensible answer to any question on any subject. Otherwise, it is not a real cosmology. Cosmology is supposed to be the umbrella under which all of our understanding exists. Right now, it has no connection. That umbrella is, lost Mary Poppins, it's off. So we need a new cosmology, and to begin with, to do that, we need new wisdom. And when it comes to wisdom, if you like, a critical view of science, the best people to look to are some of the top cartoonists, and also people like John Cleese.
And what I realise at 75 now is that almost nobody has any idea what they're talking about.
I felt very strongly about that because I'm practically a contemporary of John Cleese. There was another fellow who I came across in the early 1980s, another polymath, a British member of Mensa, who had wide-ranging ideas, and he wrote this book, The Cult of the Expert, and pointed out how it was actually working against science. And he talks about, blah, blah, blah from the expert, And as I said earlier, the language of modern physics is practically meaningless because most of these significant underpinnings are missing. And as I said, energy and mass, for instance, are undefined. And if you look in a dictionary, you will see a description of the mass of something like E in E equals mc squared, and within a few sentences, they've substituted the word matter, because it starts with M as well. However, mass is a property of the matter, and it can change. It depends upon the energy. Mass is an energetic variable. It is not. So when you measure the gravitational field of a planet, you cannot say what it's made from, how dense it is, and guess about what's going on in the centre, because that mass is a variable. So we're in the crippling grip of specialism, which, as I said, Jacques Barzun said, is a crabbed guild spirit. In fact, Halton Arp, who is the fellow dubbed the modern-day Galileo, described it as a medieval guild approach in modern science. So I'm just giving a brief idea of how I got all these ideas, bit by bit, over the decades. I started out as a very curious kid. And my favourite book of the 1940s was How and Why It Works, because it had these wonderful cutaways of everything from telephones to washing machines, jet engines, the lot. It was wonderful. But there is no how and why the universe works in the 21st century. We have funny-looking diagrams which we can't actually relate to because it talks about things we don't understand, but it gives that as an answer. It is not an answer. Later in primary school and beginning of high school, I was loaned books by Fred Hoyle because I was in an unusual circumstance. After the war in Melbourne, in Australia, there was a glut of kids suddenly arrived on the scene, so they had to begin building new schools. And the high school that I entered, I was one of the first pupils in it. And there were no higher forms all the way through that high school, which was a unique situation, pretty much. We had the teachers at full attention all the way through. And the science teacher I remember very well because he recognised my interest in astronomy and used to lend me books by Fred Hoyle, who has said, the Big Bang had seemed to him to be a very unsatisfactory theory. Of course it was, and he came up with the steady state theory, but was eventually pushed aside. Interestingly enough, Fred Hoyle knew about Vellikovsky, who I'll talk about in a moment, and he also supported Halton Arp, who I've mentioned, and I'll continue to mention, because he was the modern-day Galileo. While everyone else was looking the wrong way down the telescope, he was actually mapping what the universe was trying to tell us. And here's the guy who changed everything. I read this Worlds in Collision midway through high school. My first reaction was, this is an amazing story, but how can all of my teachers be wrong? And so I sort of let it stew in the back of my mind for a few years, but before I went to university, I read it again, and I felt that he'd made a case that could not be ignored, despite what the astronomers were trying to do. And so in the university, I was interested to pursue this or the ideas of Vellikovsky, and I thought, here I can have freewheeling discussions with people who should be able to answer questions. I found that wasn't the case. In fact, I either got hostility in return for asking the question, or the question was answered with something that the person knew about, but had nothing to do with what I'd asked about. And Fred Hoyle, in fact, met Vellikovsky, or at least heard him, and said, could it be that Vellikovsky had revealed a situation that astronomers are under a cultural imperative to hide? I would say that is correct. That was a correct assessment. They did not want to know that the past of the solar system had catastrophic overtones. We did not want to know that the solar system could not be trusted to be clockwork. He said, could it be that somewhere in the shadows there is a past history that it is inadmissible to discuss? He was right. The only problem with the book Worlds in Collision is, of course, that there was no evidence in the book of actual collisions. But Vellikovsky threw down a gauntlet to astronomers by saying that it appears from his research that in these thunderbolts of the gods, as they were called, which bore no relationship to puny sparks we call lightning, meant that there was an electromagnetic aspect to the mechanism of the solar system which had been overlooked. The response of the astronomers, those who actually read his book, most of them were happy to throw fuel on the flames of trying to burn his book, that boasted they hadn't read the book, simply because it disobeys Newton's laws. Now, you've always got to be very careful when an expert proclaims a law to you, because all laws are man-made and are open to question. So nobody picked up the gauntlet, except a few individuals around the world who got together some years later, and I'll talk about that now. Some of the questions that Vellikovsky raised were, if the planets were always tiny points of light in the sky, as they are today, why was the red planet Mars male always and the god of war? What the heck gave them that impression? And why should the characterization of Mars have been the same around the world? Why was the colour red regarded as a religiously significant colour? And also, how was Mars reported scarred in battle? The problem is, Mars is so far away that we didn't even know what that little brown smudge on the planet was when we had good telescopes to observe it. It wasn't until the spacecraft flew past Venus and managed to see that colossal gash running a third of the way around the planet, called Valles Marineris, that they realised that the planet did have a significant scar which would have been visible if Mars was much closer to the Earth. And it turns out, of course, that the North American Indians called Mars Scarface. And the Greek stories of Achilles being injured in battle in the heel, the stories of the god being injured and bearing a scar is global. The other question was, why was Venus a female with beautiful long hair or a head of writhing snakes and a terrible aspect and something to be feared? The other question, of course, the electrical one, why did the planets battle with thunderbolts? What the heck have thunderbolts got to do with planets? They're supposed to be neutral bodies orbiting a neutral star. And then, of course, his last question is, why are we haunted by doomsday fears today? I mentioned that earlier. One of the big objections to his work was you cannot prove anything from myths and legends. Well, I felt that he had. He'd taken a forensic approach, which anyone doing a criminal investigation would do, but he put the whole human race under examination and found these common elements which you just could not ignore. However, he wrote Earth in Upheaval, and that was published in 1956, where he shows that the Earth has a recent catastrophic history too. And once again, the European scientist, Georges Cuvier, the well-known geologist, was reported to have said that you've only got to take a shovel out into the countryside and start digging, and you'll see that the Earth has suffered paroxysms of what he thought were global dimensions in the past. But uniformitarian dogma has prevented any such research. Everything is interpreted in uniformitarian terms. Vellikovsky said scientists exhibit a need not to know. And that's, I think, true. When I got to university, the physics building had embossed over the entrance the School of Natural Philosophy. However, when you look at the dictionary, it says natural philosophy is the study of nature and the physical universe before the advent of modern science. We have not done natural philosophy, which was originally the role of the thinkers trying to put this big pattern together. They got tossed out. So that was the view of Vellikovsky when I entered university, and to raise the issue meant that they thought I was talking about some cowboy who had rode Venus the comet around the solar system. And that was a kind of cartoon version of their belief about Vellikovsky. As I've said before, we must return to classical physics of the 19th century when all of the big advances were being made in electrical theory and the understanding of electrical discharges in low-pressure gases, which is crucial to understanding stars. And once you do that, you can restore the standards of length and time and define mass and energy. You must do that to understand anything in physics. The electric universe says that it's very simple. There is only a single force, the electric force. You don't have to invent more forces, and don't give prizes to people who do, because that only sends you off on false trails. There is an ether. We don't understand light. It cannot be a particle or a wave. It is a wave. It is a disturbance in a medium. Quantized effects are due to electrical resonances in matter. Magnetism is due to the response of the electron and the proton to the electric force. It distorts them and forms tiny dipoles at right angles to the impinging electric force. And gravity can be explained by the offset of the nucleus of an atom in a gravitational field. And then you come to plasma cosmology, which is the only successful explanation of the motion of galaxies and the fact that they take the form that they do, the spiral form. It is the most magnificent scale view of an electrical discharge in space, gathering matter together. And then, of course, if you're going to do a cosmology, you need to use the most number of records you can from the past to understand that today's sky is not the way it was more than 10,000 years ago. This fellow, David Talbot, beginning in 1972, was responsible for the publication of a series of journals, Ponce, from the University of Oregon, I think it is, in Portland. So there's 10 issues published between May 72 and winter of 1974-75 by the Student Academic Freedom Forum, whose president was David Talbot. And Dave's initial article in Ponce became the #1 bestseller on several college campuses, inspiring stories in Time magazine, Newsweek, Physics Today, Chemistry, Industrial Research, World Medical Tribune, and numerous other publications. Both Reader's Digest and Analog magazine published cover stories on Vellikovsky, and 2 documentaries on the Vellikovsky question played on Canadian public television and British public television, both rebroadcast due to popular interest. Planetarium programs based on Vellikovsky played to overflowing audiences. The eventual result of the new public interest was this 10-issue Ponce series. Now, that David Talbot and his brother Stephen organised the first international conference on Vellikovsky's work, and the theme was the recent history of the solar system, which of course was a red rag to a bull for astronomers and to the AAAS, the American Association for the Advancement of Science. So in early '74, just before this conference, they organised a special session of their annual meeting in San Francisco, and they set it up as an ambush to try and discredit Vellikovsky. It's an interesting story, and the book, The Vellikovsky Affair, edited by Alfred de Grazia, came out shortly afterwards, detailing all of the bad behaviour that occurred. David Talbot then in 1980 published The Saturn Myth, which I bought and read. And on the cover, that strange-looking image is what he called the polar configuration. It was seen around the world, and it was stationary because the central object in that picture was situated at the North Celestial Pole, so it remained fixed in the sky. Now, this was totally against anything that Newton or any of the modern-day apologists could explain, so of course it was ignored. But it was based on Vellikovsky's unpublished work, which showed that the earliest recollections of the sky had a different sun in the sky, which he identified as Saturn, the son of night. And out of this, that inspired David to do a lot of research on his own and produce this book. What's more, it turns out that it seems that what we call Protosatin, because Saturn developed into the spectacular object we see in the solar system today over a series of events. But it inspired the universal myth of the Saturn's lost golden age, the planet's astronomical identity as the ancient sun god. All of the old references to the sun, Ra, Helios, Sol, referred to Saturn, not the present sun. And also it dealt with the preposterous original location of Saturn at the celestial pole. Now, the people who were the forerunners of an electrical view of gravity, amongst them was Faraday himself. He said he thought often about an experiment that would connect gravity and electricity. And he said no terms could exaggerate the value of the relation they would establish. Because in the 19th century, they were looking for simplification. They didn't want to invent new forces. They wanted to understand the forces they had in terms of the electric force, because it was almost universally recognised in that century that electricity had some fundamental significance in the functioning of the universe. Sadly, we lost that. Then in the later 19th century, I've already mentioned Wilhelm Weber and also Professor Assis, who's I'm very pleased to say is with us, and this is the book that he and several other co-authors have produced, and it is one of the most important books I've read. He derived an electrical gravitational force law. He had a planetary model of the atom 40 years before the atomic model of Rutherford and Bohr. And this theory is quite simple. It just requires that you give up the idea that the speed of light is a limiting factor on the transfer of information, because the astronomer Tom van Flandern pointed out that if the Earth had to wait 8.5 minutes for the gravitational force from the sun to arrive, it would be pulling us to a place where the sun was 8.5 minutes ago, which is the same as swinging a lead weight around your head. Your hand is always slightly in advance of where the object is to keep it spinning around your head. But if that string was to break, the stone would, or the lead weight would fly away. And it's the same with the standard model of gravity, Newton's law. If you try and introduce a time delay, the whole thing is incoherent and will fly apart. And as this incoherence that's introduced by Einstein's speed limit that operates at the atomic level, the subatomic level, at the level of the solar system and the level of gravities. It cripples our understanding of the universe. Cardona is the chap I mentioned, who has done an enormous amount of research and published. Initially, he inspired me with his articles in Chronos, which was published after the Ponce series ended. And in the autumn of 1977, he published The Son of Night, which really caught my attention, because there he started to analyse scientifically the idea that Vellikovsky had put forward, that Saturn played a major role in the Earth's environment in the past. And this was followed by these massive volumes of his, the star series. There's a primordial star, the newborn star, flaring star, all of these things which had to be explained by some new theory of how the universe operates. And that was my challenge. Erik Birkeland is another pioneer of the electric universe. He was the guy who investigated the auroras, and he came to the conclusion that space is full of electric particles, and there are electric particles of both kinds, positive and negative, electrons and protons, coming from the sun. He was correct. His Norwegian Aurora Polaris expedition, those two books there, were published in 1902 and 1903. And in those books, he shows that he could explain the rings of Saturn, the sunspot cycle on the sun, comet tails, comet behaviour, all of these things well in advance of the works that we do now on the electric universe. So he was one of the major pioneers. In the middle of the picture there, you can see his Torella experiment, which was, in some respects, the forerunner of the Sapphire project, because we wanted to repeat his experiment, but under controlled conditions and also based on a new model of how stars work, electrical model, which involved a slightly different approach, and also modern instrumentation to find out what's going on in that chamber. Irving Langmuir was a pioneer of plasma physics. He was one of these multi-talented guys who won his Nobel Prize in surface chemistry in 1932. But he too was interested in low-pressure gas discharges. You see him there holding that discharge tube. And he found that charged objects embedded in plasma, and plasma is the separated particles, positive and negative, that you find in space. They're ubiquitous in space. He found that they form regions of space charge, which he called a sheath, a Langmuir sheath. He, in fact, with his knowledge of biology and chemistry, surface chemistry and so on, coined the term plasma because of its lifelike characteristics. You've all seen those novelty plasma balls with the snaking filaments. You can see why he thought that it behaved like something that was alive. Winston Bostick was another plasma experimenter, and he produced an experiment where he fired what are called plasmoids. Now, plasmoids are a phenomenon known in plasma experiments where you have a discharge between two electrodes which is shaped in such a way that the current flows into a central point and it tends to spin around and then it twists and it twists. You've heard of the old tungsten lamps with coiled coils. Well, this is a coiled coil. The result of that is that you can concentrate a phenomenal amount of electrical energy in a very tiny space. You can put all of the power of a room full of capacitors into something a few millimetres across. Where do we see something like that now? In the centres of galaxies. So what did Winston Bostick do? He fired two of these plasmoids at each other at right angles into a magnetic field, and they formed this spiral shape that you see there in that little picture. The other thing that he did, which is important, is he considered the electron had structure. Modern physics assumes that the electron is a fundamental particle. Well, no one knows what fundamental means when it comes to particles. He said, no, it must have shape, it must have structure. And it's obvious. If you're going to produce a magnetic field with an electric field, you've got to have matter responding in some way, which means that it must have a structure to be changed. Dr. Charles Bruce in the 1940s, he's another one of these intuitive wonder boys. He was a member of the Electrical Research Association in the UK. He was a doctor of physics, and he attended Sidney Chapman 1941 Kelvin lecture on the sun, which led him to apply his ideas, electrical ideas, and that to cosmic phenomena and to a new all-electric universe. So he's one of the people who could claim to be one of the fathers of the electric universe. So that was in 1941. He said, the surfaces of stars can be explained as lightning discharges which are observed in the atmosphere of the Earth. In a simple way, he was right. It's more complicated than that, but we'll come to the guy who figured it out. But he said something else interesting. He said, in fact, it may well be that both Jupiter and Saturn were at one time minor stars, and that their satellite systems were formed as a result of minor or planetary nova outbursts. A nova outburst is where a star sheds a lot of matter suddenly in a brilliant display, and the material that's ejected often forms a satellite or a partner. Here's the guy who really was up there with Vellikovsky in terms of inspiring me. In one of the Kronos journals in, what was the date on that one? 1979. He wrote an article which began not one of the observed aspects of the sun is predicted or explained by the thermonuclear model. When I saw that, I said, yes, he's right. But then he went on to describe what he felt from an engineering perspective was the closest analogue of the sun. And it turns out it's an arc searchlight. He then looked at all of the literature on plasma discharges in low-pressure gases and found that he could explain the granulation of the photosphere, which is not explained by convection. Convection would give you like a boiling porridge. It would be completely random. It's not. Each of those little granules grows, stays bright for a while, and then fades, and then it's taken over by the ones that move in and take its place. None of that is explained by convection. As he said, I think convection defies all of the observations. On the right, you can see a sunspot. This is detailed pictures of a sunspot. And you'll notice that it's not convection. You've got these long filaments with dark centres, or dark end centres. And on the right, what I did was I found a fiery tornado. They had a helicopter engine on a tower above, and then they poured fuel into this fire at the bottom, and the twisting vortex shows you that you'll get brightening along the edges because that's where the fire is more or less thickest through, and it appears dark along the centre column. And in the close-up, you can see, if you look closely, the centres of those long filaments that are stretching across the sunspot, which I've shown in more detail at the top, are dark. They are plasma discharge vortexes. Now, discharges in plasma tend to take this filamentary, rotating behaviour. That's their natural state. So the sun's lightning doesn't look like lightning on Earth, and this is to be expected, of course, and then the conditions there are quite different. And also the power input is quite different. The thing is that to reproduce this in the laboratory requires that you plug the thing into a power source. So the question then is, well, where's the power source of the sun? And that was one of the big questions that he also looked at. But the answer came from Birkeland. Birkeland and his Birkeland currents, as they were named after him, take that form, but it's even more complicated than that. They take a very complex form which explains so much about what we observe in the behaviour of stars, the formation of stars and so on, which can let us understand for the first time how stars are formed, how they're born, how planets are formed. They're all formed in the same process. Planets are not leftovers. They're not formed by gravity, they're formed by the powerful electromagnetic force. You need a more powerful force to bring the matter together, because it's only then that gravity takes over. Gravity can't produce gravity, it'd be a bootstrap, which is impossible. So all of this hangs together, and I thought this was brilliant. The other interesting thing, I mentioned Hans Alfvén shortly. He's the Nobel Prize winner in plasma physics, and he didn't consider the anode. When we talk about this discharge, in any discharge there's an anode and a cathode. The anode is the positive charged element, and the cathode is the negative charged element. And the electrons tend to flow from this end to that end, and any positive charged particles tend to drift in the other direction. Hans Alfvén considered the anode unimportant. I think the reason for that is that in electronics, one of the big requirements of the old thermionic valves, as they called them, remember the old valve radios and TVs, was to heat up this central filament, the heater they used to call it, to emit electrons. So all of the attention was on the cathode, because it was critical to actually produce the current and make the valves work and your TVs work and so on. The anode was just this metal plate or ring or cylinder which sat around the cathode. So all the focus was on the cathode. This guy figured out that it had to be the anode, simply because of he's looking at it from an engineering point of view. Those little anode tufts is what happens when the discharge current density rises to a point where the plasma needs to change its behaviour to accommodate that plasma density. So bright stars are covered in anode tufts. Each of those long discharge objects that you see in the close-up is an anode tuft actually stretched over thousands of kilometres. Too much detail. Professor Earl Milton joined with Juergens, and he was associate professor at the University of Lethbridge in Alberta, Canada. He was also a good friend of mine. He came out to Australia when Halley's Comet was in the sky and stayed with us for a short time. And he came out a couple of times, in fact, and spoke to groups that I organised to talk about Vellikovsky and Juergens and people like that. So he was important. Alfonse's Electric Universe, he had an article published in the Boston Globe in 1989 which was titled Alfonse's Electric Universe. Of course it says it's a big aurora, it's far more than that. But he also, in his Nobel Prize acceptance speech, did something that was unheard of. He warned that there would be an inevitable crisis in astrophysics because astrophysicists were using a simplistic version of his theory that he no longer felt was correct. In fact, he knew was incorrect. So he warned that there would be an inevitable crisis. Look at that, 1970, and what is it, 2019 now, and that crisis is only just beginning to make an impression. It gives you an idea of how hard it is to turn the juggernaut of the Titanic of physics away from the iceberg. In 1979, I'd met Vellikovsky at the McMaster conference that I showed earlier, and he even referred to me in the final speech as somebody who'd come from the ends of the earth to this conference. In 1979, I was working for the government in Washington, D.C. for a short time. I rang his home and asked if I could visit. I had a question for him, and it related to gravity. I said, everyone said that your work disobeyed Newton's law. I said, what is it we don't understand about gravity? And he gave me the first clue where to look, because he'd written this small pamphlet back in 1946 where he argues that gravity is a dipolar electric force. That was the clue. Thank you, Vellikovsky. Then just 2 years later, I noticed a tiny advertisement in the Scientific American by this fellow Ralph Sansbury, who was publishing himself the Journal of Classical Physics. And the first issue had an article on the structure of an electron. And that gained my attention immediately because obviously matter has to have a structure to do all of the things we observe. That was his home laboratory. I visited him at his home in upstate New York in the early 1980s. But from his work, he explained magnetism and gravity as the response of the orbitally structured electron and proton to the electric force. It was as simple as that. Now we come to Halton Arp. Now his work is absolutely monumental. It's crucial to understanding the universe because it was he who, with this little diagram here, showed that quasars, which are those objects strung along those lines, were ejected in pairs along that spin axis, and as they come out, they're travelling at high speed and very high redshift. But over time they slow down, they gain mass, and they go into orbit about the parent galaxy. Their redshift decreases to normal over that period of time. So something is going on at the subatomic matter inside those bodies. And so his cosmology is absolutely crucial to be able to address with the electric universe. If I couldn't answer his questions, I didn't have an answer. I'm happy to say that I finally managed it, but it was a little after we had lunch together in London in 2000 before I hit on some of the crucial aspects of it. He was also a winner of the Sagnac Award from the Natural Philosophy Alliance. The Portland Symposium was important because that's when I journeyed from Australia at Dave's invitation to present something. I just rang him out of the blue and said, I'd like a copy of your book. And he said, no, you can't have it, it's out of print. I said, but he said, have you got something you'd like to present at this conference? And I said, yes, I have, about the incredible youthfulness of Venus. So he said, right, over you come. When I met him over there and saw his work, I collared him in the lift. I think Ben, our videographer here, was there at the time. And I said, I think you and I should work together because your work and mine is more powerful than either of us trying to do this alone. In 1996, I went over and spent a whole month camped on his office floor while we prepared slideshows for a meeting in 1997 where I used the term the electric universe for the first time. He's gone on to produce these amazing videos, symbols of the alien sky and symbols of one was about the lightning-scarred planet Mars, the other was an introduction to all of the symbols. And then we have Professor Donald Scott, who joined us in the 1990s, and his engineering background, he was able to deduce more things about Ralph Jurgen's model, showing that the photosphere behaves in a transistor-like fashion and keeps the output, the radiant output, steady. His book, The Electric Sky, is recommended. And the historic Portland meeting, where modern plasma physics converged with the prehistoric petroglyphic evidence, was one of those turning points in history, I reckon. Plasma creation, this is Tony Peratt's work, and he was a leading plasma physicist, and these things over here, that purple plasma, were named after him as Peratt instabilities, because he's the guy who discovered them and named them. On the right are the papers he published showing how they allied with petroglyphs carved in rocks in prehistory. My contribution was to write articles trying to understand the physics. And in Eon, which is one of the journals that was published by Eduardo Cardona, I explained the polar configuration for the first time. And some of my papers are listed there. And finally, The Electric Universe was written in concert with Dave Talbot in 2002. And just recently, February this year, Gaia.com TV put out a 7-part series where I and Ev Cochran, who is another one of these mytho-historians, and a scholar who followed Dave Talbot's work, did interviews for 2 days, and that was made into a 7-part series. The thing is, to go forward and to understand the universe from the electric universe point of view, we must reconnect with our past. We must pay attention to what people like the Australian Aborigines, who are featured here, were trying desperately to have us understand. And those figures that were projected on the Opera House on the right-hand side are these famous Wandjina figures, as they're called, from the Kimberleys in the northwest of Australia. Those figures, they say, the head dress with those radiating lines is lightning. They're quite specific, that's lightning. The figure with the 2 eyes and the nose, the eyes are not eyes, they were something quite different, they were obvious in the sky, and the nose is not a nose, and they use the words, the nose represents the power flowing down. What were they talking about? And yet around the world, the figure of the god with the tongue, red tongue hanging out, or these ones often have a red bib. You can see the major one there. It's got something hanging around its upper chest. So the present state of the electric universe on the thunderbolts.info website is excellent. They've got those major feature-length movies at the top, all available online. There are over 100 Electric Universe conference talks by leading scholars and scientists, because this is an inclusive, I mean, we've got artists, we've got scientists, we've got engineers, we've got laymen, all contributing. And this is what I encourage, because I recognised early on that trying to confront the beliefs that we hold at present requires that the public participate and demand change. We've got over 250 episodes in the Space News, 40 episodes of Discourses on an Alien Sky by Dave Talbot, who I'm pleased to say is actually producing them again. And since 2012, our YouTube channel has experienced exceptional growth, with over 22 million views and now averaging almost 500,000 views per month. And with that, I finish.